Hello everyone, my name is Elisa Baum and I am Percona's Director of Product Marketing. We'll begin in just a moment, but first I'd like to conduct a little bit of house cleaning. First, can you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know if you can hear me? Okay, great. I see a lot of people's hands. Thank you very much for helping me on that. All right, next, during this webinar, you will all be on mute. Should you have any questions during the discussion, please enter them in the question field within the control panel. At the end of the webinar, we will take time to answer as many questions as possible. Those that aren't addressed will be answered in a follow-up blog entry on Percona's MySQL Performance blog. In addition, a recording of this webinar will be made available to everyone within 48 hours. I would like to thank you for attending today's webinar, Best Practices for MySQL Scalability, presented by Percona's CEO and founder, Peter Zaitsev. And with that said, I'd like to turn the floor over to Peter. Peter.
Hey, thanks, Elisa. Good day, everyone. So today we'll talk about best practices for MySQL Scalability. So we'll look into their MySQL Scalability identified areas, which impact, and provide a best overview for practice in those areas. This is rather conceptual introductory presentation, right? So we won't really go deep into a lot of those topics because any of them, frankly, could take a webinar or even a whole training day on its own. So first, let's talk what about their scalability. And different people are thinking about different things, right, when you talk about scalability, because we may need to scale in different terms. We may need to scale our application in terms of handling different amount of users. We may have to scale in terms of data size and database size. We may need to scale in terms of hardware size, being able to handle larger loads with more powerful hardware, or sometimes even scale down, being able to ship our application in with a smaller hardware requirements, right? And in this case, we would define a scalability up and down, right? Scaling up meaning scaling with more powerful environment, and scaling down going to a less powerful environment. Now, for this presentation, we will take a very simple and practical definition of scalability. We will talk about scalability as often happens for successful systems. Scalability with system growth, right? Which typically means scaling with more data, more users, higher concurrency. Often there will be also more and different kinds of queries because we are introducing more and more complicated features. And all of those things really happen at the same time. So working with scalability, we really have to be thinking about lots of things at the same time. Now, when we talk about scalability, there are multiple components we have to be thinking about, right? We have to be thinking about the application architecture, hardware, the operating system and configuration, what kind of MySQL version they're using, MySQL configuration. We have to ask ourselves whether our schema is designed properly and whether our queries are optimal. Now, what is interesting here is what we really need to make sure we are doing reasonably well in all of those areas. Because if we screw up in any of those badly, even if we did very well with others, that may not be enough to provide the decent scalability for a system. For example, you may have a very powerful hardware, but if you have queries which do full table scan or worse, some full joins, then you wouldn't be able to scale the application right with the best powerful hardware. Now, when we talk about the architecture, I think the first thing to understand is that the MySQL is only one of the tools which are available for you. There are many other tools which you can use together with MySQL to upload certain things. That could be Memcache for caching, Sphinx for full-text search, Hadoop for large-scale data processing, MongoDB in cases you need to store some non-structured data, right, which are all very feasible solutions. The second conceptual thing I like to point out with architecture is before you really look into optimizing something, you have to be thinking about the elimination, right? It was always very surprising for me how many applications have queries which are not really needed or do something else which is not necessary to begin with. So think about how you can stop doing things you don't have to do. On the database side, that may often mean that you upload things from database to somewhere else. The most simple concept is caching in Memcache or in your application somewhere else, but as well as eliminating queries which don't produce results which you're using in the application is very important. Removing duplicate queries, that's another typical optimization strategy. The second thing to think about is really latency. In a lot of cases, our response time for user actions such as page use may really be dependent on the latency of the queries to the database. So what you can do to really deal with that latency? Well, first, you really want to limit number of queries. Right? If you can use less number of queries with the same complexity to do things, it is better. It's also a good idea to run queries in parallel, especially if you have a complicated application which talks to multiple MySQL servers. If you use Java, you can very successfully use multiple threads. If you use PHP, they also have created this new MySQL ND API which allows you to run asynchronous queries where you can issue queries to multiple servers at the same time and then wait for response for all of them at the same time. It also helps to know network topology, right? Because we may be thinking about the network as something fast, right? But in fact, it can be a very limiting factor if you have significant number of queries. And changing, for example, from web server talking to a database server with single hop, right, to some more complicated environments when you have to go through several hops and router, right, or few of them, which all introduce latency. The difference in performance may be very significant. The second question I would think about architecture is wherever single node is good enough for you, right? The single MySQL server can handle a lot, but if you're really looking at the large-scale application view, this wouldn't be enough, and you need to think about the strategies how you can go beyond single node. And often it is good to think about those things well in advance, because if you are already running into, well, running out of capacity a single node provides, that may be very stressful to try to migrate their application to some different environment. The other interesting component when it comes to MySQL is to control concurrency. And by concurrency, I mean number of connections which are actively running transactions at the same time. What is interesting with MySQL, well, as frankly many other systems as well, is what it has a certain concurrency which is its most optimal, which typically will be below 100 of queries which are running concurrently. There would be some other range where it performs more or less okay, but if you're speaking about tens of thousands transactions trying to run them concurrently on the MySQL server, that will be very, very bad. It wouldn't scale at all. And what that means is you want to think in your architecture how you can ensure to control this concurrency of MySQL. For example, if you are using Java, you can configure your connection pool appropriately, right? So it would not go beyond certain number of connections and introduce queuing as needed. Now, as I mentioned over the previous slide, the single node architectures are quite limited, right? So there is only so much we can get from their single node, and often we'll have to go to more than one node in terms of scaling our reads and writes. MySQL offers a number of choices in this regard. The most common and commonly used is the MySQL replication, which is rather simple to use and which you can especially scale reads very well. That is a very common strategy, but it doesn't scale writes very well. Right? I would say even more, if you're using the MySQL replication, amount of writes you will be able to handle is likely to be much less than single node, because replication is likely to be the bottleneck pushing through the writes to the master. The MySQL cluster is another approach, which is very powerful in terms of being able to scale reads and writes up to a few tens of the nodes, but it has some other limitations to that, and it is a very different piece of technology compared to conventional MySQL and InnoDB installation you may be seeing. So it's good to evaluate. Just don't expect you to be moving the application with no changes to the cluster technology. Percona XDB cluster and other Galera-based solution, which is a relatively new solution on the market. We have released Percona XDB cluster SGA just about a year ago, and this is essentially their synchronous replication solution for the InnoDB storage engine, which is a lot more simple to use and understand compared to some other clustering technologies. At the same time, it provides their very good scalability and clustering, because it can replicate transactions concurrently, as well as it provides you the ability to write to any nodes in the cluster and read from any nodes in the cluster as well. It's also worth to mention the Clustrix, which is their commercial implementation, which is comparable with MySQL on a protocol level. Meaning it's really a software which was implemented from the scratch, right? So it doesn't use any MySQL code, but it is comparable in terms of MySQL protocol and most of the functions. This technology is scales pretty well, but again, similar to MySQL cluster, it's rather different from its behavior compared to a conventional MySQL server. Now, to look at the multi-node architecture from a different dimension, I should mention sharding, or people sometimes call it also the component as a pods, where we would essentially scale our system by having different, have data split into smaller components, right, and manually spread them across to multiple servers or sets of servers, right? I mean, if you are in MySQL space, there is a lot of very prominent users such as Facebook, which are using this technology very successful. Now, you can either do it manually, or there are a number of other solutions which can help you to automate some of those. You can look at the solutions as Parallastic and Scale-based, which are commercial solution, or ShardQuery as an open source. Now, one of the questions I often ask is, hey, do you actually really have to shard? Isn't it kind of painful? Shouldn't we look at the systems which automate everything for us? And my approach to that is as follows. On the lower end, you often would be enough of a single system. If on the middle end, you really can use solutions like Parallastic and others to avoid need for sharding. Maybe go to 10, 20, 50 boxes, MySQL boxes. Now, if you go to significantly higher than that, if you look at indeed of a Facebook scale, right, or something like that, then probably you don't want to have all your data in the same cluster anyway. Because think about that. What would happen if something goes wrong with your cluster, which has a few petabytes of data? How much trouble that will take to recover all of that from backup or really troubleshoot it to a certain extent? Typically, we try to keep data in those clusters, tightly coupled clusters, which are relatively manageable if they have to be troubleshooting, right? Because no software or hardware is absolutely reliable. Going back to the hardware, I think it's very important to understand how far you can really go on hardware alone those days. If you look at the number of published benchmarks for powerful servers, you can be looking at 200,000 or even up to 300,000 of simple lookups to MySQL tables a second. Now, if you think about that and say, hey, well, my page on average does 100 queries, right? And that will allow us to do something like 120,000 pages a minute. And even if we account for some high day usage or night usage, this is close to 80 million pages a day, which is a pretty high number, right? So the point here is what there is a very high number of applications which can work very well with a single server. Well, maybe not quite a single one. Maybe you have another server which is running for high availability purposes, right, or to get you a copy of data for some reporting or development purposes. But you should not undervalue how much you can really get from a single beefy box of space. When you go at the specific hardware recommendations, I would look at the following things. CPU, you should go for fast cores. Right? Those days you can get a lot of cores, and for many MySQL workloads, you will see not all of them will be able to be used completely. Going for faster cores means you will get advantage for all workloads. Going for much more but slower cores will only benefit some, but will show up as slower in others. Right? Also, the cache as fast memory bus is important, right? But those typically come together with the newer generation CPUs, right? So look at the CPU generation as well as their the family, because as well as the frequency, right? Because newer generation CPUs are more optimized. Memory is often the most important component for performance, because when data is in memory, it can be accessed much faster than it is on disk, even if you're speaking about the solid state drive, right? So getting a large amount of memory until your working set fits into a memory well is very good investment. Also, as you're looking at the memory, you can look at that in a reverse way as well. If you have a less memory, that means more pressure on I/O, right? And that also means if you are having their very powerful I/O subsystems such as solid-state drive, sometimes you're able to operate effectively with lower amount of memory, which can be efficient from cost or power saving standpoint. Then we speak about the storage in terms of hardware. The fastest storage you can get those days is directly attached flash, right? In terms of performance, you can't really beat that. And not only what you can't really beat that, but modern PCI Express cards provides you more IOPS than a single MySQL instance would be able to consume. Right? So they provide a lot of I/O to very low latency. If you look at PCI Express cards, the Fusion I/O, Vidident, Microns, these are the some very good vendors which we tested, and they work pretty well. Now, if PCI Express cards are very expensive for your budget, or if you're looking at relatively large amount of space, so it becomes expensive, look at the solid-state drives. Those days they are becoming increasingly affordable, and you can pick different drives depending on what is your workload. If you don't really modify your data a lot, you may be able to use rather inexpensive MLC drives for consumer market rather effectively. What is important with solid-state drives, though, is that not all vendors are created equal. You can find the basic specs like, oh, this is the MLC hard drive for 256 gigs, right? And you'll find tens of different vendors providing the same hard drives. But they can be very, very much different because there is a lot of differences in internal design as well as the software or firmware which operates on. Keep that very much in mind. With some vendors we have, and some firmware configuration, we have a lot of weird effects to be honest. Sometimes you'll have SSDs which would work well, and then they would stall for example, 30 seconds every half an hour or so, which is often unacceptable. If you are looking at the conventional drives, well, first I would only use conventional drives if you need a lot of space. I mean, you can get probably about 4 terabytes for less than $200 those days, right? I mean, nothing beats those volumes. And they can also provide a pretty good sequential read rate on cheap, right? But if you're looking for random IOs, they are not even close to what SSD can provide. But anyway, if you're using the conventional drive, ensure you have a RAID with battery backup cache, especially if you are looking for transactional workload, because having their durable transactions they create, it works much faster. If you look at the RAID level advanced, I would say the RAID 10 is the best choice for heavy load. But this is for heavy load. Sometimes you may need to use space more effectively. In this case, you may use RAID 5 if your write load is not very high, or read prevailing load that can be quite okay. So what is about Sun? A lot of people ask me, hey, I mean, when you're speaking about the storage, why don't you mention Sun? I mean, in our enterprise, we run a lot of Oracle and we use a lot of Sun systems. My answer to that is you don't use Sun or NAS systems if your goal is raw performance, right? Because, well, PCI Express systems, Flash would be much faster than those. When we look at the Sun, it's typically when we have a flexibility of size and sharing resources. If you have a requirement, for example, to be able to scale some system from a couple of hundreds of gigabytes to tens of terabytes of storage without any re-engineering, right? Then Sun provides that very well. And in some cases, that is the very important requirement. A lot of people also use Sun for various additional features, such as storage replication, including offsites, backups, including setups with continuous data protection, where you can essentially always go back in time and say, hey, can I just restore all the data on this file system for yesterday at 5 o'clock, right? Or support for snapshots. For a number of enterprise environments, these may be a lot more important than raw performance. integration with clustering and virtualization, that may be another reason people are using SAN. But again, all those features are absolutely great, but it's not going to give you the best performance possible. So let's now talk about the network configuration. So when you speak about the network, mind the latency, the first and foremost. In majority of the cases, you would not be out of the network bandwidth unless you're doing something very strange, right? You will much likely be performance limited by latency. And to minimize latency, you want to minimize number of hosts between database and web server, and also try to have those hosts to go through switches because they don't introduce as much latency as a complicated firewalls or routers. Ensure you're running at least 1 gigabit link speed. I have seen a number of cases where for some reason the link speed was negotiated at 100 megabits, and that was causing a lot of problems because it's really easy to run out of bandwidth for 100 megabits a second. Sometimes you need either to go further and go to 10 gigabits Ethernet, right, or a network bonding trunking, right, but that's would be a rare case. What is also interesting about network is what the network problems are often blamed on database. In a lot of cases, you would see what database is not performing, but as a closer look, you can see that is a network problem, not the database. So what I learned from that is what it is very important for DBA to have some access to network monitoring tools. So you know how low the database network is, if there is any queuing happening, if there is a packet loss, right? So you can really cross-check what's happening with network without really involving the whole other teams. Virtualization and the cloud setup. Now, there are a lot of MySQL being used in virtualized environments in the cloud. And if you would be in the same room, I would ask you guys to raise the hand. Probably there would be a fair amount of hands for people running virtualized MySQL or doing that in the cloud. What is good, and this is a very fair thing to do. There are a lot of good reasons to do that, but it's good to remember what virtualization overhead, whether it's in your own enterprise environment or in the cloud, and what typically their most powerful hardware would not be available in a with virtualization, right? So just keep that in mind, designing their architecture. What is also important in this case is to really know what is available to you, right? For a while, I think until just the last year, we had this very bad limitation of if you go into the cloud and Amazon, the storage will be very slow, right? I mean, we just wouldn't get any decent I/O software. So we would have to design systems differently which don't rely on a fast storage a lot, right? For example, ensure we have almost all the data set in memory, and then MySQL on EC2 was working very well. Now the situation has changed, and we have rather high-performance flash storage, right, and provisional I/Os available. So that means we can engineer the systems a little bit differently. So know what's available for you. I'm surprised how often there may be a disconnect about the assumption between what DBAs may need and what the system group is able to provide. Just last month, I've been speaking to a team and say, hey, well, for your workload, you probably will need to get the MySQL with 256 gigs of memory, right? Well, not a big deal those days, right? I mean, it's not really a very large system. And they would tell me, hey, well, we run on the virtualized slice, and in our virtualized slice, the largest amount of memory is available is 16 gigs. Oops, that's a problem, right? Make sure you know what your system team or your cloud provider can provide you and factor that in your architecture choices. Operating system. Well, Linux is by far the most common choice, right? There is, well, I guess, no surprise here. And the important thing, you want to choose a recent kernel, which supports your hardware well. That especially applies if you're using a flash storage, because there is a lot of work going on improving the Linux kernel and file systems to get advantage, most advantage of this storage. In terms of Linux distribution, I would suggest using the server-grade Linux distribution, Red Hat Enterprise Edition, CentOS, Ubuntu, LTS, Debian, right? Stick to those because, well, getting something which is desktop-based may not offer the best performance, as well as you may have too aggressive updates which can cause some problems over lifetime of the system. In terms of configuring the operating system, well, frankly, for most workloads, you don't really need to tune too much on the operating system configuration. I typically like to set up LVM because it gives me a lot of flexibility in configuring my storage differently, while unless I'm using snapshots or something like that, there is a very little performance overhead, but I have a lot of flexibility if I need to do something. SE Linux, you want that disabled unless you really need that on your system. It often makes little sense because in majority of the cases, MySQL is essentially the only tenant of the box, right? So you don't really need to isolate multiple users from each other that goes well. There is only one user anyway. In terms of file system, XFS and ext4 are probably the most commonly used high-performance file system for MySQL. In different workloads, we have seen different performance between those two, and even between those two file systems, you can see the very significant performance difference, sometimes over 50%. So I would suggest to try what works best in your circumstances. Another thing we like to change operation system is to reduce your tendency to swap with changing the M swappiness, setting that to 0, for example, as well as to adjust the Linux disk.io scheduler, typically setting that to deadline or even no op is a better choice than CFQ, which is still default for many operating systems. When it comes to the MySQL version, the user versions as general scale better. So MySQL 5.6 is likely to be the most scalable, especially after a few months until it will be fine-tuned. You still know about some cases when MySQL 5.6 performs slower than MySQL 5.5 as it is now. And then they also are working on even more optimized version of Percona Server 5.6, which is due to be out of this summer. Will merge some of our Percona optimization that was found in MySQL 5.6. So if you are just starting your development project, I would suggest you start developing with MySQL 5.6. It has a lot of new nice features which you can use, right? And it also will simplify your migration later on. If you are just using older MySQL version and thinking about the upgrade, I will wait for another 3 to 6 months to let this version to stabilize a little bit better. Another important thing about the MySQL build is consider using official build from some respected providers if at all possible. We have seen so many cases where bad builds which haven't been compiled and tested properly would be causing everything from some very bad performance, for example, having builds which have been accidentally built in debug mode, to the over-optimization, right, using some unsafe and untested compiled options, which would then cause MySQL crashes in production, which could be avoided, right? You don't want to do that. You don't want to face the stability for those another couple of % of speed you can get by those advanced optimizations. MySQL configuration. Well, the thing to know with MySQL is what you need to tune MySQL configuration, right? I mean, if you just get MySQL default settings, it will not most likely perform at the best possible level. The MySQL 5.6 defaults have been changed, and they are better than they had been before, but they're still unlikely to be optimal, especially for larger scale systems. I don't have the time to go into a lot of configuration options, even though I will note you, but I have a different presentation about their MySQL configuration tuning, which you can check out. And note, even though there are hundreds of variables available for you to be tuned, really you need to get only a handful of them to get a different performance. If I would have to choose only very few variables to tune in a DB-powered MySQL, I will pick those few. Set init buffer pool size appropriately. If a box is only running MySQL, you may set it to up to 80% of memory. Right? If it's shared or something, well, you have to adjust that. init flash method or direct is best, and also adjust init log file size. Try to set it to 256 megs or more. And keep in mind, they're larger log files. That means you will have a better performance for writes and more uniform performance. But also, if MySQL ever to crash, you will have longer recovery time. Right? So if you are experimenting with the larger log files, it's typically good to test by crashing MySQL and see how long it takes to recover. Schema design. Well, I would, first thing I would say to avoid is just a textbook schema, right? I mean, if you would go read some academic books about the schema design entities relationship, you'll probably come up with a very good normalized schema, but chances are it wouldn't be able to support your queries very well, even if you try to index everything properly. Instead, what I would suggest is to really understand how a MySQL optimizer works, what it can do and can, and see how your schema is going to support your performance critical operations. Both reads and writes, right? Both of them are important to think about. In a lot of cases, you have to use some additional tricks, right, which are not very academic ones, such as generalizing data, having some summary tables, or caching some data as a copy in some fields and other tables, right? Often those all tricks are very helpful. Also note what your schema for online processing may be different from reporting schema. The MySQL allows you to replicate between the schemas of different index setups, and in a lot of cases you need to go even further and run some ETL process to extract the data from your OLTP system and load that into a reporting schema in a different format, which supports your reporting needs very well. Some people those days even don't have it in MySQL. Many people extract the data from MySQL and then loaded that to a Hadoop for efficient large-scale reporting. Or in MySQL sense, they may be using the column-level storage engines such as InfoBright or InfinityDB. In terms of indexing, well, too many and too little indexes are both bad, right? Too many indexes will cause excessive disk space usage and slow your queries down, because MySQL will have to spend too much time choosing what index combination is best. And too few indexes, well, obviously, too few indexes wouldn't allow you to run queries efficiently, right? And queries will run slowly. So they have to be balanced. For that, you can check the indexing best practices presentation, which will give you some of the most basic ideas about how to pick good indexes. Another thing you want to do is to check for duplicate indexes with PT duplicate key checker. That is a very simple thing to do, and often you'll find a lot of duplicate or redundant indexes which you can drop to reduce your database size with no negative impact to your queries. In addition to duplicate indexes, it is often a good idea to check for unused indexes. In many cases, we see indexes being over time added and added as queries change and new queries are added, right? And nobody really drops old unused indexes because it's kind of scary. And if you do that at your own index, well, you may have your system essentially begin to halt, right? So there are a number of ways you can check for unused indexes and clean them up. Just of course be careful doing that. So and test carefully, right, if your new index setup works well, because missing index for some frequent query may indeed make your system completely unworkable. In terms of query design, it's important to note that queries are not really seen separately, right? When you speak about the query optimization, you have to look at the queries together with schema optimization and index design. When we optimize queries, it's a few things which are important. You need to know how to run, how to read explain statement in the MySQL. This is your best friend, right? I mean, both for developers and DBAs, that is an absolutely essential skill to be able to understand that. Second thing is what you want to test your queries, right? Don't just assume you know how MySQL will execute the query you just created. Test it, see how long it takes, what the plan is looking at, and do that on the real data and with the real kind of values in the queries. Don't just test that on a very small test database, because you may have a different plan and the query execution time may be completely different. There have been many downtime caused by developers just testing their queries in the test system and not in production. Also, think how your queries will scale, right? I mean, if you are saying, hey, we just have, well, 10,000 products in the catalog, right, but they're going to go to a few million, well, think, what is about your query? Does it have to scan every single product to sort of them, right? If it works right now with 20,000, then, well, wouldn't that number change to 5 million and become completely unworkable? Think about that as an example. And also, I would very much suggest you to establish a query performance monitoring practices. You can use PTD Query Digest, and there are a number of graphical user interface are available for that as well, such as Box Any Monitor. You can find about those at MySQL Performance blog. So what the idea here is to monitor your queries daily or weekly, and if there are some queries which start to become significantly slower than have been, then you need to examine and analyze what is going on before that becomes really critical to take the system down. Another thing to note is what you want to know, what kind of MySQL optimizer features exist out there, what queries MySQL can optimize well, and what limitation it has, and design queries appropriately. For example, for years, we could not design certain subselect queries with SQL. It would produce a very easy to read and simple query, but MySQL just wouldn't run them well, so we have to figure out how to change them to the joins, right, or maybe to multiple queries to make sure MySQL is able to execute them well. Another thing about MySQL Optimizer is what it may be smart, but it's not too smart. It will do mistakes, and more often than you would like. And so it's very important to know how you can force Optimizer to behave a way you like it to behave, which are Optimizer hints, such as force index or straight joins. And in MySQL 5.6, you can also use Optimizer options to enable or disable certain optimizations as they apply to their to a given query. Well, that's about it. I also want to point out where you can, on learn more on this and related topics. Check out the Percona training. We have a lot of training offerings, both on-site as well as virtual, public, and private. Now our trainings cover MySQL 5.6, and we also have a special training which is focused on migration to MySQL 5.6, if that is something that you are considering. And also, we welcome you to attend more of our webinars. On May 15, in fact, I will be talking again about MySQL performance schema, and especially using that with MySQL 5.6. And on May 31st, where Bill Caravan will share a lot of his insight about their query optimization. Thank you. Now I can answer some questions.
Thank you very much, Peter. I'm going to go ahead and ask you the questions that people have entered into the GoToWebinar control panel field. Folks, go ahead and ask any questions of Peter. We'll answer as many as we can in the time we have left. Anything that's not answered, Peter will address in a follow-up blog post on MySQL Performance blog. So with that said, Peter, here are some of the questions that we have. Is there any reason not to use Barracuda table format for InnoDB?
Yes, well, I would say Barracuda table format is good. Those days, right? It was around for a significant period of time, and it has a number of features, right? So you should use them. There are some edge cases. The previous antilope format may be a little bit more efficient, but that is something you can validate with your own test, and this is quite unlikely in most cases that it works same or better.
Okay, great. The next question is, how do you measure the working set?
Oh, that is a very good question, right? In fact, working set is not. You cannot say the number, right? Working set is just 5 gigabytes, right, or whatever, because it may depend on the period of time, right? You may say whether in average in hour you have, let's say, 10 gigabytes accessed, but now in day it may be different, right, or even if it be a different number again, right? So on the practical purpose, what I like to see in the working set is I define a working set deals well in memory, then I can keep my system using the CPU effectively, right? So it would be essentially CPU bound, not IO bound, right? And how we can test that is by essentially testing the different ratios of data to memory workloads. Some of you may say, hey, I'm running, for example, 10 terabytes, right? There is no way I can fit in 10 terabytes in the box, right? And then go from that and test different memory amounts and see what kind of performance I get. Well, in those cases, it's often a good idea to see how you can scale down your workload, right? Maybe you go from 10 terabytes to 100 gigabytes, and then you can test the conditions from just 1% of data fits in memory to all the data fits in memory. And then you often would find something like, oh, you know what, at about 50% of data fits in memory, I see what I am already the CPU bound, and the future memory increases, they don't really provide any substantial performance gains, right? That is then your working set will be considered fit in memory.
Okay, great. How do you measure the number of hops between web server and database server?
Well, that is an interesting thing, right? I mean, because on a different level of networks, you may have different ways to see it, right? If you look at the routers, you can use a traceroute tool to see how many hops it happens. But this would not see your switches. It wouldn't show your switches, right? Because switches they don't really show up in those tools. And in this case, it's good to also just know your network diagram, maybe talk to your network guys, right? In some cases, like a cloud or somebody else's data center, that's not really visible very well. And in this case, it's often also good to simply test it. You can run a ping and see what kind of speed you're getting, right? And or response time you're getting and how it varies. Typically, I would expect to see about 0.3 milliseconds, right, or 300 microseconds as a reasonable time for a system which is connected through a single switch, right? And you can essentially go from there to estimate how much longer it is.
Okay, great. What are some of the common reasons for InnoDB table corruption on high write volume tables?
Well, InnoDB corrupts. Well, I can tell you, you are very unlucky, right? Because that's not very common to happen. I would say in majority of the cases that we have seen table corruption caused by some other factors in MySQL. Some problems with file system storage, sometimes drivers, cables, or all this kind of stuff is a very common problem. Even such things as memory, right, especially when it doesn't have ECC, can be caused that. Sometimes it's also could be bugs in MySQL. Over the last couple of years, I've seen the handful of bugs fixed which could actually cause the database corruption. And I would say in terms of where they would more often happen would be compression, if you're using that, and use of the blocks. Right, the block code is kind of not very clean in the they have to handful bugs as well.
Okay, great. Is it a good idea to mix SSD brands models in RAID 1?
Well, I think what you're trying to reach, right, in this case is to ensure, right, if one of them fails and unreliable, another probably will save you. I would not probably be doing that, because that means you can be exposed to their more complexity, right? And let's say if one of the drives would stall, and then it would be scheduled to that portion, right, you have your system exposed to that stall as well. I would, in the end, think about something else, right? Is what when you speak about the RAID, right, or the storage, plan what any storage can pay. Even if you have a very expensive RAID, right, it does not guarantee what the data will be saved forever. It simply should be designed what to avoid a nuisance for you. It will fail sooner or later, right, completely, right, and carry data with you. But you don't want that to happen very often, right, so you have to, I don't know, rebuild the slave, right, or switch to the slave. So my solution would be to make sure you don't rely only on RAID for data protection. Have something as a slave you can fail over to if you master this to fail, or to use backups and things like that.
Okay. How well does Percona cluster scale the writes? It looks like the fact that each node must perform the same amount of writes should be a limit for that at some point.
Yes, that is a very good question, right? And this is indeed, so their Percona XGB cluster can limit the write scalability because of all the nodes have to execute the writes. It is hard when in case of MySQL replication, because in this case all the writes can be performed in parallel. There is something else which is important to understand. In a lot of cases, when you think about the write statements, let's say I'm writing an update, it's not just do writes. It also have to do a lot to find the data to modify. And this read component of the writes, depending on workload, can go anywhere from 20 to 80%, I would say. And depending on your write workloads, that means you may have a very high scalability even then you issue a lot of writes to the cluster, right? If they have this high portion of reads in there.
Okay. Which replication is better, RBR or SBR for performance, or does it matter?
Well, that's a very good question. It's statement-based replication or row-based replication. And the answer in this case is it depends. Right? Depending on your workload, it may be one or another. Think about that. If you have some single statements which modify a lot of data, then in this case you may have a lot of better with statement-based replication, because you wouldn't have to pass so much changes through a network, right, and process them. In other cases, then you may have a statement which has to find a lot of data, right? And let's say you're doing some update which is doing a full table scan, right? On your master statement level replication, that will have to do a full table scan on the slave as well, while row-based replication will just store rows which needs to be updated. Right? So there's a lot of influx. Now, I would say the benefit of the row-based replication in a lot of cases, it sets less logs, right? Which high concurrency is very powerful. And also it's designed to be more reliable, because statement level replication has a lot of gotchas, right? How a slave may be getting a little bit different results out of the statement execution.
Okay. You mentioned that smaller log files equal quicker recovery time. The attendee was under the impression that the checkpoint target age was more important in recent versions. Can you comment on that?
Well, yes, that is a good point. Now, what is interesting in this case is what this checkpoint target is essentially defines how much log space the MySQL will use, right, in your log files. So if you have your log files at several gigabytes, but your checkpoint target is just 100 megabytes, well, MySQL will just behave as if your logs are 100 megabytes, right? You wouldn't be able to, get the advantages of a large log files if your checkpoint target is small.
Okay. For multiple tables that have 3 to 4 million rows, is PT Archiver the best way to optimize performance in keeping row count down if the rows are not actively used?
Well, archiving the data is one of the good strategies to use, right? And if you are to archive the data, PT Archiver can be a pretty good tool for that. Now, wherever is the best tool, right, or other strategies which would apply to your case, that's hard to answer about taking much deeper look.
Okay, and we have time for one more question, and I would just remind the audience that any questions, and there are several, that were not addressed will be answered in a follow-up post by Peter. Okay, so Peter, what is the best practice to avoid replication delay?
What is the best practice to avoid replication delay? Well, I think the best practice here is really to monitor your application utilization. You can do that. You can look at a blog post on MySQL Performance blog about how exactly do that, and there is also a post by Mark Leach about how to do that with MySQL 5.6 performance schema. In a sense, you want to see how much your thread is busy, right? And if it's getting close to being constantly busy, then chances are your replication will start lagging soon, right? Another cause of a replication lag would be spiky load. For example, people would start some bad job, right? 20 processes concurrently, which will write the data to a master as quickly as they can. Well, that will clog the replication and the lag will happen, right? You want always to be careful and gentle and not issue too many writes, right? But space them in time. Finally, take a look at the long transactions, right? Remember, the replication would typically go in the single thread, and it will serialize all transactions one after another. So you have a single transaction which runs for 2 hours and modifies 500 million rows, right? Then that means the slave will have to essentially stop, right, for a few hours and do the same. So try to have your transactions which are small, right? Don't replicate alter tables, for example. You can do them on or on the slave as well, or use PT online schema change, right, which doesn't do that in the same transaction, right? So there are a few of those tricks you can do.
Okay, well, thank you very much, Peter, for your time today, and thank you, audience, for joining us. Just a reminder that I will be sending out a link to the recording of this webinar and the slides within 24 hours. And again, thank you for your time today. Have a good day or good
Thank
evening.
you.
Bye-bye, everyone.